Hi everyone, this is the second example of chapter 9.4. It is question 209. Let's read the question. Question 209. Determine the wavelength of the third Balmer's line. So it's a transition from the fifth level to the second level. So the only two pieces of information we're given are the level. So the lowest level being 2. Remember, M here represents the lowest level. N is equal to 5, the highest level. So we want to find the wavelength. We need to find what will be the energy of the photon being emitted. So basically, the energy of the photon will be equal to the Planck constant multiplied by the frequency. It will be equal to the ionization value, which is 13.6 electron volt. Now, here's a catch. In the previous problem, we took the energy in joule and we converted it into electron volt. It was easier. But the problem is, this term over here is in joule. That means if we want to find the frequency, or in this case the wavelength, which is linked to the frequency, we need to convert that term in joule. Now 13.6 electron volt is equal to 13.6 multiplied by the value in joule of 1 electron volt, which is 1.6 multiplied by 10 to the power minus 19. Now, the remaining term over here is 1 divided by 2 square, so the lowest level, it's m square, minus 1 divided by 5 square, which is the n square, basically. Once we combine everything, we get the energy in joule of 4.57 multiplied by 10 to the power minus 19 joule. So this transition will create a photon with this amount of energy. Now, we are looking for the wavelength, not the frequency, so we can replace the frequency with the speed of light divided by the wavelength, and at this point it's a simple matter of isolating the wavelength, and we get a value of the wavelength is 435 nanometer. So a transition from the fifth level to the second level emit a photon with a wavelength of 435 nanometer. All right. So this is the last video on this chapter, and it is actually the last video of this semester. So it was a pleasure teaching you, and don't be shy to ask any question in class if anything is unclear. The remaining exercise in this chapter are not much more complicated than that one. All right? So see you in class.